This is a short version of the notes from section 6.7, which is on inverse functions. The first type of problem we looked at was one like this, which is actually a continuation of 6.6. It's asking for f of g of -1, but instead of them giving us equations for f of x and g of x, they gave us a graph here of f of x and g of x. So to do this, first thing I would do is I would rewrite this just like we did last class. Rewrite it as f of g of -1 like that. G of -1 wants to know when x is -1, what is g of x equal to? So when x is -1, g of x is this graph right here. It's the y value of that point. So 0. So I'm going to replace g of -1 with 0. Now it wants to know what is f of 0. So when x is 0, f of x is 3. Let's try this one, f of g of 3. F of g of 3. Again, I'd rewrite it like this. G of 3, when x is 3, g of x is -2. Now it wants to know what is f of -2. When x is -2, f of x is 5. And then the new section was 6.7 on inverse functions. Inverse functions are two functions that undo one another, that cancel out each other. To find an inverse function, we are going to switch x and y. Switch the x and the y value. The notation that we use, it looks like this. Looks like it says f to the -1st of x. This is the inverse of f of x. Or f inverse of x. So to find an inverse relation, if we have points here, part A just asks, is this a function? Yes, it's a function. Each x has its own y. Nothing new there. To find the inverse of this, we're just going to take the points, and as we said before, we just switch x and y. So we switch the x and the y value of each point. So notice in the original function, the x value of 6 had a y value of 9. If I then take 9 and I plug it into the inverse, that 9 maps back onto 6. So it cancels out whatever happened in this relation and gets me back to the original x value that I had, which was 6. So it's canceling out, it's undoing whatever the given relation did. Notice this one is not a function. X value of 4 has two different y's. Most of the problems will look kind of similar to this. First thing, make sure you understand that this notation means the inverse of f of x. That's not taking f of x and moving it down to the bottom because it has a negative exponent. This is looking for the inverse of f of x. To find the inverse, we switch x and y. F of x is the same thing as a y. So we have x equals 4y minus 12. Add 12 to both sides. Divide both sides by 4. X divided by 4 plus 12 divided by 4. So f inverse of x is equal to 1/4 x plus 3. We could verify that that is the inverse of f of x. We could take any x value. Suppose we choose x equals 5. If I plug that into f of x, if I plug in 5, I get 20 minus 12, I get 8. If I then take 8 and plug it back in over here, I get 1/4 of 8, 2 plus 3. I get 5. I get that same x value that I started with. F inverse of x cancels out whatever f of x did and gets me right back to where I started. Basically, f of 5 was 8, therefore f inverse of 8 needs to be 5, the x and the y switch. Example 3 asks us to find g inverse of g of x equals x squared plus 3. We start by switching x and y. Subtract 3 from both sides. Cancel out a squared by taking the square root. Anytime you take the square root of both sides, you need plus or minus out front. G inverse of x would be equal to plus or minus the square root of x minus 3. I'm not worried about this part. Find the inverse of this guy here. This one's a little bit more difficult. Start by switching x and y. And this one's harder to solve. We're trying to solve for y. We cannot cancel like 4 over 2 because this isn't divisible by 4. Instead, we're going to multiply both sides by y plus 2. It would look like this. Distribute the x. Move all the y's onto the same side of the equation. And anything else over to the other side. So this xy I'm going to subtract. I'm going to add 4 to both sides. And I'm subtracting xy. Remember, I'm trying to solve for y, so we're going to factor a y out here. And divide by whatever's left over. And I've got y by itself. So the inverse, f inverse of x, is equal to 2x plus 4 over 3 minus x. And then the last example here gives us a graph of y and asks us to show the graph of y inverse. Need a few more points this way. -3, -4, -5, -6. All you're going to do is take a point. This point here is -2, -6. And we're going to switch the x and the y. So that point is now going to be -6, -2. -1, -1. If I switch x and y, is still -1, -1. -3/4 0 would now be 0, -3/4. And so on. 0, 2 is 2, 0. This would be 3, 1, 2, 2. 2 and 3/4, 0, 0, 2 and 3/4. 3, -1, -1, 3, and then we've got 4, -6, so -6, 4. So y inverse would look like that, kind of. I missed a couple of these points, but you get it. The other important thing to know, notice these two graphs, the way they're related to each other, they're reflections over the line. That line right there, which isn't a very good straight line, the line y equals x. F of x and its inverse, f inverse of x, are reflections over the line y equals x. If I take this point and I flip it over that line, it winds up right there. If I take this point and flip it over the line, it winds up right there. And so on. This point's right on the line, therefore I can't reflect it, it winds up right on itself. Same with that point. That is section 6.7 on inverse functions.